since you're starting, okay, it's already recording as well.
Okay.
Okay, I see Ankit Agarwal, Shilpa joined. Hey guys, thanks for joining. We'll give another 5 minutes for folks to join in, and then we'll start. I see more folks. Hi, Maru, Randy, Sheila, Susanna. Thanks for joining. We will start in just a couple of minutes. We have an amazing session today. Testing shift left, right. We're gonna learn a lot about the testing methodologies in Agile with our amazing speaker, Nick, aka Dhaval. Let's give another couple of minutes. Stay tuned. Yes, Karen, the recording is started and we'll be recording it, and we'll have the link for the recording after the session, maybe a day or two after today. That's a good question. Thank you. Yes, we do have a YouTube channel. We do post the recordings. Maybe Meenakshi, do you want to share the link when you get a chance for all our recordings?
Yep, sure. I'll share the YouTube. Yep.
Thank you so much. Yeah, we have a lot of amazing recordings from the previous session, so that might interest you, and advise you to go over and check out those videos as well. And going forward, we will be recording this and also posting this session also. That's awesome to hear. Maru says 70% of all the talks I've attended, so that's great. Also, do let us know if you want any specific topic of interest. We'll try to figure a good speaker for that topic as well. Anything that you would love to learn more in specifically related to Agile, maybe it may be an Agile process related, DevSecOps.
Or if you want to present at LAN, yeah, we would love to have you present at LAN too. We do awesome. Have backlog, yeah. I don't know about Maru, but it's open to everybody else. I'm just kidding, Maru.
That's right. Toby's so right. And if you have a burning topic, and we love to bring your personal experiences to our LAN meetup. So, feel free to reach out to us with your topic, and we would love to see you speak. Okay, the quick time check. It's 7:05. So let's give another minute or two. We have about 7 and 5 panelists, so 12 altogether, but let's give another minute or two.
Yeah, Susanna, I think Nick will cover a little bit on test-driven development, I'm sure, today. But if you want that as a specific topic, we'll definitely take a note of that.
It is 7:05.
Mm-hmm.
Hey, Ankit, by performance management, do you mean human resource performance management as in your appraisals, or is that management of performance of your system? Okay. Good to know, yeah.
I see Jessica joined the session. Hi, Jessica. So while we wait, I will give a brief introduction about our LAN meetup and also co-organizers here, and then about Dhaval, the speaker, and then we'll jump into the session. So thank you everyone for joining this evening with us. I know time is very critical. It's a beautiful, beautiful evening, and I really appreciate you all joining today to learn about the testing topic today. So this is Lakshmi Mutiala. I'm one of the co-organizers. Along with me, I have Toby. Toby is an amazing coach, organizer here. I have Anju Baraya. Hi, Anju. And I have Meenakshi. Meenakshi, I don't see a picture, but I see a beautiful picture. We have Avinash also, will be joining soon. Here are the co-organizers for the LAN meetup. And today we have an amazing speaker, Dhaval Nick Shrimankar. He goes by Nick. So a little bit about Dhaval. So Dhaval is a technical agile DevSecOps coach. He's very passionate about everything about DevSecOps. So Dhaval and I work together for USPTO, and I see his technical assessment, solutioning, very amazing. He works with the teams to help, and leadership to help teams to get into the all things about DevSecOps, does amazing workshops, test-driven development, behavior-driven development, and everything about testing, and also about good practices, engineering practices in general. So here we have Dhaval to talk about today about shift left, shift right, continuous testing in DevOps. So we talk a lot about testing, we talk a lot about Agile, but only few teams does really good with testing. And there is so much of emphasis on how to do testing right, in the right way. So shifting, we're going to learn about what is shift left and all things about testing today. So Dhaval, without any further delay, I will give it to you. And we'll have question and answers in the last 10 minutes. So if you have any questions, feel free to ask in the chat. We have Anju monitoring the chat window, and we'll be able to answer all the questions about 7:50 time frame. All right. With that, I'll give it to you, Dhaval.
Thank you. Thanks, Lakshmi. Just one last final check. You can hear me?
Yes.
Okay, awesome. All right, so let's get started. First of all, thanks everyone, and thanks to all the organizers at the Loud and Agile Network for this great platform and giving me the opportunity to speak. Some of you may have seen me. I used to hang out at quite a few different Agile meetups years ago, eons ago, it feels like, now with COVID in play, and when we were attending in person. But for those who I haven't met, I'm looking forward to some great questions and conversations going afterwards. Okay, so that being said, let me jump into it. Just wanted to give a real quick background. when it comes to testing in IT, software development world, everybody jumped onto the wagon and caught on with the buzzword shift left. And it got to a point that now shift left has become very ubiquitous. You hear shift left literally with anything and everything, whether it's testing, security, thinking of delivery, planning, all sorts of stuff. People love to throw those two words together, like, hey, why don't you shift left? That's great. And in our software development world comes DevOps and DevSecOps. Along the line somewhere, shift right also came into the picture. And as I progress through the slides, you will see what I mean by shift right if you haven't already heard of that. Okay, and then eventually I'll build a case of continuous testing, and I'll touch on the concepts. So even though I'll talk about the how, it is again going to be very conceptual. We're not going to do any kind of deep dives. Okay, just to put the background here. So I'm going to cover the traditional model. Let me see if I can get a laser pointer going. So I'm going to cover the traditional model, what it looks like, what shift left looks like, shifting right looks like. I'll cover these two models here, Agile and DevSecOps, leading into end-to-end testing, and then finally the how. Okay. Again, as I said, the how portion is going to be high-level concepts. If you have questions, you want to jump into details, you can always reach out to me. I am available on LinkedIn. I pretty much accept everyone. And I'm always available to get into a conversation, especially when it comes to technology, whether it's testing, DevSecOps delivery, creation of pipelines. You want to talk about AWS Cloud, Google Cloud. I'm all ears. Okay. So let's proceed. Jumping ahead, just a quick note, no automated testing, no DevSecOps. Okay, I said that. If you want to argue with that, once again, I am available on LinkedIn. Feel free to ping me, and I'm happy to listen to you, if you disagree with me. Okay. So starting with the traditional model, most of you are familiar with this. It looks like waterfall, and it is waterfall. We start with requirements, we jump into analysis, design, and then we code, we test, and we hand it over to the operations. And I have this box around code and test. It's because whatever testing that happens, it is only related to coding. Whatever has been coded is being tested. Okay. And the alternative, what is outside of this box, you will see in upcoming slides. Okay. I think most of us are in Agile world today. We all know the benefits and disadvantages, benefits of Agile and disadvantages of waterfall. So these three shouldn't be of any surprise to you guys. Testing occurs very late in traditional model. It is limited to coding, and requirements aren't tested. Okay, so there are assumptions that are made when requirements are gathered, and they're analyzed, turned into designs, and then eventually coding and testing. Okay. Here's another model. A lot of you may be familiar with it, the V model. So if you're looking at a timeline of events, you have business requirements gathering, which moves into system requirements, and then high-level design, which furthers into low-level design, and then ends up into coding. Okay. And then on the validation phase, we've got the unit testing, component testing, integration testing, and acceptance testing. So this is a very linear approach. If you haven't gathered requirements, then you don't know what the system requirements are going to look like. If you don't know what the system requirements are, you don't know what the high-level design is going to look like. So you could verify these, the left side of the V on its own, but you cannot validate any of these items unless you have your unit testing done that would validate your low-level design, whether your design is on track, whether whatever a developer is assuming and thinking, they don't know if it is accurate. Okay, no matter how senior they are, it is very hard to have that assessment unless and until any kind of testing is done, right? So as I said, this is a timeline here. So if you look at it, the time between business requirements and acceptance testing is the widest, which means you cannot validate your business requirements well down the road in your program when you get to your acceptance testing, right? And many times we have heard from our customers or stakeholders that, this isn't exactly what I was looking for, or this is not at all what I'm looking for, okay? And so on and so forth. So that's just another downfall of the traditional V model. So again, I spoke about some downfalls. The biggest one, in my opinion, again, I'll throw another buzzword, human-centered design, right? But we completely take the human element out when we are following the traditional model, right? We have no involvement of testers. And let me make it clear, testers doesn't necessarily have to be people who have the technical background. Okay, we've got something called user acceptance testing. Oftentimes users are not technical, okay, but they are never involved early on in the planning phases, right? So if you just envision the V that I was showing you earlier, if you're on the left side, none of those testers are involved in any of those analysis or design phases. Okay, many requirements, architecture, and design defects are not uncovered and fixed until after significant effort. Again, as I was saying, you're on a timeline, and if you're on the right side of the V, significant amount of time has already passed. Assuming bugs are identified, then it's a nightmare to debug the code because a lot of the code has already been integrated and identifying that one little point in time where the issue could be. It would be very time intensive, not to mention it will cost a lot of money as well. Okay, and anybody who's been tester before, they will attest to this, that they never have enough time testing because development spills into the time frame that is allocated for testing, and testers are oftentimes putting in 10, 12, 14, 15 hours because now their time frame has been reduced. Okay, when it comes to a traditional model, a lot of the testing is manual, and that's where a lot of the issues stem from. And then let's assume that a bug has been identified, debugging has happened, and a remedy also has been identified to eliminate that bug. Guess what? Oftentimes the developers will cut corners or write very brittle and flaky code because they need to meet that deadline of deploying the software. Okay, we have some great high-profile examples. Was that the Affordable Care Act website that went down because it couldn't handle issues, and not only couldn't handle the traffic, it just wasn't performing the way it was supposed to. And there are many more. You can just Google some of the high-profile failures when it comes to software launches. So that's all about traditional model. I can go on forever, but that we're not here to talk about traditional model. So what has happened in the last few years? What is this shift left testing, right? So some of you have heard of it. Okay, so you probably can understand this. You're working in any kind of agile frameworks or methodologies where, if you're looking at a timeline, you have got a user story that is being groomed. Eventually, it's fully baked and ready for coding, and then it's tested. And once all of that is completed, it's handed over to the operations for deployment and monitoring and so forth, right? The idea of shift left testing is that we shift the testing to the left. Okay, where do we shift it? Are we replacing it with the coding? So the coding happens here and then test happens, or grooming and even before the user story has been baked, where? Okay, and I'll talk about it in upcoming slides. From an academic definition, shift left testing is an approach to software testing and system testing in which testing is performed earlier in the life cycle, right? Moved left on the project timeline. And it is the first half of the maxim, test early and often. So we're only thinking about the test early, not often yet, okay? And I'll talk about often when we get to the continuous testing part. And then in the last few years, something called shift right testing has emerged. And what is shift right testing? Okay, so shift right testing, as you can clearly make out, it's opposite of shift left. It's an approach where testing is performed in production. Okay, a lot of people say, oh, you cannot perform testing in production because we're not supposed to mess with the production data. Yes, I agree with them wholeheartedly, and they're absolutely correct, but you don't need to mess with the production data. Okay, there are ways when it comes to technology that you don't need to look at live production data. Okay, you could have test data in your production. Yes, you can. Okay, how, again, that's out of the scope of this conversation, but just bear in mind that you can have test data in your production, right? And there are various different types of testing that you can conduct in production. And I'll show you some of those in upcoming slides. So that essentially is shift right testing. Okay, there's not a whole lot more to it. You're essentially, what you're doing is shifting your testing to the left, meaning once you get your requirements, that's when you start not only verifying your requirements, but also trying to figure out and validate those requirements, okay? And then once everything goes into production, you continue with your testing. You just don't stop suggesting that, oh, I'm done with my product, it's out there, let's forget about it. No, you continue with your testing. And what that testing looks like, I'll touch upon it briefly in upcoming slides, okay? So Agile model. Everyone's familiar with these wonderful loops, correct? You go through your review, design, you go through your builds, tests, and then you review, right? And then you move into your next iteration, next sprint, whatever you want to call it, and then the next, and then the next, and then the next, right? So you will notice that there is a testing here. What is this testing related to? Often it is whatever has been developed here is what is tested here. Okay, and at the end of the sprint, what happens? Some kind of integration, the code has been merged into your repositories, and you get into your next sprint, and everyone forgets about the stuff that's merged into the repository. And the question then arises is, where do we execute integration or regression tests? Do we execute here, or here, or anywhere within a sprint, or here? Some of you must be very familiar with the concept of release cycles, where you have a release will have multiple iterations. And then towards the end of the release, you will have a testing iteration or a testing sprint where you're doing nothing but testing, right? I'm pretty sure it sounds like waterfall. All you've done is shrunk your waterfall into a 3-month period or a 2-month period, okay? And you're just calling yourself that you're being agile. I'm not here to argue with anybody of the definition of agile. If that works for you, great, okay? But in my opinion, and in a lot of experts out there who follow DevSecOps with a passion, dislike that model, okay? So if you are engaged in that model, think how this relates to you. Where are your tests being performed, your integration, your user acceptance, your performance tests? When do you run those? Just before a big bang deployment into production, or within each and every sprint or your iteration. Okay. And then next is the DevOps model or the DevSecOps model. Security people don't get offended. DevOps, DevSecOps, it's all same. Okay. Same thing, right? You go through your planning, your coding, your building, and your testing. And then you release it, you deploy it, you operate it, you monitor it. But same question, when and where do you run your integration and regression tests? Execute your user acceptance tests or your performance tests and whatever, okay? Just have these questions in your mind, at the back of your mind. And then comes end-to-end testing. What does that look like? So this is what it looks like. We spoke about shift left and we spoke about shift right. End-to-end testing is we test literally every different phase. If you're in user story grooming phase, you have a testing hat on. If you're in your coding phase, you have your testing hat on. You're in the operations, you got your testing hat on. What it's post-operation, post-deployment, once it's in production, you continue to have your testing hat on. Okay, and that's why it's referred to as end-to-end testing. So how does it look like? As I said, in end-to-end testing, you test everywhere. Okay, so if you're in a planning phase, you test. If you're coding, you test. Building, you test. Testing, you test. Release, deployment, operations, all of that. Okay, let's just make sure that you are testing, having your test hat at every moment while you're going through your software development. Okay. So now we're going to talk a little bit about the how. Let me just quickly see the time check. Okay, we're close to 7:30 and we're good. Okay, so when it comes to shift left, okay, one way to do is by taking an approach of what is called test-driven development. If you're not very familiar with it, don't worry about it. But what test-driven development allows you to do is, first and foremost, you write a test, okay? And again, this is automated testing. So when I say you write a test, you're writing a piece of code, all right? This is not like writing steps in plain old English and following through. You're actually coding. So that's what I mean by you write a test. And the second step is you execute the test, and the result of that is going to be a test failure. Okay, because there's nothing to test yet. You've only written what do we call a shell. Okay, and then the next step is to write code. Okay, so it's kind of an oxymoron here because, as I said, when you write a test, you're coding. All right, and whether it says write code, you're writing your business code or your logic code. Okay, and then you repeat the process as in you execute your test. All right, and when you execute your test, your code will compile and the test will run. And if there are any issues, there are two types of feedback: a developer, or if you're there's a title called software development engineer in test. So if you're a developer or SDET or whatever title you like to call yourself, you get two types of feedback. If there's a compilation error, obviously you know that your code isn't compiling, so there's something wrong. But let's say if the code is compiling, but your test is failing, meaning your code is not in compliance with the requirement, because that's what you're testing. Okay, your requirement. So you got to update your logic, got to update your business code. You should not be updating your test, but with a caveat that there will be instances or occurrences where your test is wrong. Okay, and there's nothing wrong about it. It is quite possible that you don't know what you're testing, and that's why you have a wrong test. Okay. The positive out of that is you haven't gone too far down in your software development lifecycle timeline. Okay. So because you haven't spent so much time, now you know that you need to look at your requirements and you need to reassess the tests that you're writing. Okay. So those are some of the high level TDD benefits. All right. Again, I'm not going to dive into too deep. I'm going to keep it very high level. There's an ocean out there, or ocean of information out there with regards to TDD. Okay. What test-driven development will allow you as a technical person, if you're a developer or tester, is to write two types of tests: unit tests and integration tests. Okay, so once again, think of the V model. Remember, if you're on the right side of the V, the very next thing after coding is unit test, and then component and integration test. So component, integration tests, they could be identical at times, but with test-driven development, you can knock out both unit and your integration tests. I want to talk a little bit about unit tests. Within unit tests, you could have different types of unit tests. One unit test is simply going to test the functionality of your class or whatever that is you're writing. Okay. The second type of unit test is you need to look at security. If you are writing APIs or microservices, you can write security-oriented unit tests. Okay, so if anybody who's a cyber person or a security person, there's your limelight. Security is always embedded in DevOps. Okay, so DevOps, DevSecOps, it's all one and the same. You should always have the security posture in mind. And using test-driven development, when you're writing a test, you can write multiple different types of tests. So what am I saying here? If you have a class can have multiple unit tests. All right. It doesn't have to be one unit test in one class. Oftentimes you will have a lot more unit tests for one class. Okay, so just keep that in mind. And then coming down here, back to this loop, let's say if the tests are passing, what's the next step? The technical person can refactor the code. Once the refactoring is completed, they can check in the code into the code repository and move on to the next user story or whatnot. Okay, so that essentially on a high level is test-driven development. There's something called BDD, or behavior-driven development. It is an extension of test-driven development. You can shift your acceptance test to the left. So I spoke about unit tests, security tests, also part of unit tests, and integration tests. Okay, now we're talking about acceptance tests. And you can shift those acceptance tests to the left by automating them using the behavior-driven development methodology. Okay, it opens up a lot of communication between the stakeholders, between the business customers and the technical side. Okay, and I'm saying technical side because you could have developers, you could have testers, database folks, security folks. They all need to have collaboration with the business side to understand what those acceptance criteria look like. So it's a great way to have that clear understanding beforehand. Okay, so when I said shift left all the way to the story level, that's what I meant, wherein all your technical people are involved, collaborating with your business folks and just asking questions, simple questions, prodding questions, like what exactly are they looking for, trying to understand what the business wants, okay? And then with the help of technical folks, as a team, they come up with an acceptance criteria, which eventually turns into an acceptance test, okay? And that acceptance test is part of automated testing, okay? So if you look here, you've got your features, which are distilled into stories. Then you move into your TDD phase. Once everything looks good, you deploy it. You pick up more stories. Well, let's say if you're done with all the stories under a particular feature, then you pick up a new feature and more stories and so forth. Okay, so that's essentially what the flow looks like with behavior-driven development. Okay, so shift left. Again, this is a quick time flow in your timeline. You create tests, you run tests. If they fail, you write code. Then you run the test, meaning you're testing your code, whether it's fail or pass. If it's a failure, you go back and fix your code or write more code, whatever needs to happen. If it passes, you refactor the code. Then you run the test again. Hopefully it will pass this time. And if it's passed, you check in your code. Okay. So essentially that's what the flow looks like. A little bit continuing about the acceptance test is you start with a test. It's an acceptance criteria in a simple format. The language is called Gherkin, okay, and the format is given when then. Okay? It's a style of representing tests, and it's specifying a system's behavior using specification by example format. Okay. So here's an example, right? You got a feature you want to identify or check whether it's Friday or not, okay? So the feature, you've labeled it, is it Friday yet? Everybody wants to know when it's Friday. And this is how your acceptance criteria could look like, okay? So you have a scenario and your test is Sunday is not Friday. So you need to test today is Sunday and that's not Friday, okay? So given today is Sunday, when I ask whether it's Friday yet, then I should be told, no, today is Sunday. Okay, that's your acceptance criteria. And you take this and you convert this into an automated acceptance test, which then you further distill it down into integration test and unit test. Okay, so you can automate your entire process, all the tests that are on the right side of the V model. You can automate everything, all those tests, okay? Let's talk about shift right. For those who don't know blue-green architecture, or you haven't heard of active passive, there are a few other words out there floating, but the most common way to refer is either you call it blue-green or active passive deployments. Okay, this is your infrastructure where you have an identical copy of your production. All right, so if you look here, this is your production environment, and this one is an identical copy of this. Okay, they're both identical copies, but one is active environment, the other one is passive environment. All right, so when you have customers, when they hit your website, www.yourwebsite.com, you have what is called a load balancer that will route your users into the active environment. Okay, so on the back end, when the developers and the testers, when they are writing the code and deploying it into production, they deploy it into passive environment. They don't deploy it into active environment, okay? And then once it's deployed into the passive environment, and that's where the testing happens, the sanity testing, if any kind of sampling that needs to be performed, any kind of A/B testing, UX. This is a big deal. This is where you perform your UAT, you call in your stakeholders, let them know, hey, we've deployed the new version, take a look at it. And they may not like the color, something as simple as that, right? Well, guess what? It's still internal, it's still behind the doors. Your customers have not seen this one yet. You can fix it and redeploy it, okay? Performance monitoring with any kind of new deployments into your passive environment. If the performance reports show any kind of what's the word? Any kind of degradation of the performance, well, then you know that something needs to be updated in the code and tests as well. All right. And then you can also perform any kind of analytics if you need to. All right. Now let's assume all these turns out to be perfect. All the test results are green, good to go. Okay. Then what happens? Then here in the router, you flip the switch and all your customers are now looking at the green environment, which is now labeled as active environment. And then any kind of new version goes into passive environment, which is now the blue environment. And that's where you end up doing all your tests. Okay, as I was saying, testing in production. This is one way of testing in production. The other way of testing in production is by using feature toggles, okay? So here you have new features, they go straight into the production. All of this here is production, let's on this side, okay? Just envision that. And then you've got your customers hitting the production, your website. Only some customers will see the new features because a flag has been turned on for those new customers, okay? How do you identify who those customers are? It could be completely random, okay? Think about those dumb random security checks at the airport. They randomly pick you, okay? You could have a same concept in your production, in your code, where a decision is made and randomly a different version of website is being served to different sets of customers, okay? Or you can use geolocation, where people in East Coast see a particular version, people in West Coast see a different version because of their time difference or whatever, right? Or make it international, right? If your website is being accessed by somebody in, let's say, Latin America, well, you want to show them pictures of beaches, right, and not snow, okay? So just a thought, right? And those are the feature flags can do that. So using the feature flags, you can test again in the production who sees what, so you can test that. Okay, that's another way. There, I'm only covering two of the most used methods. Depending on the need of your product, you have to look at the other different ways of testing in production. What kind of tests you want to run in production. Okay. Shifting right, so here's another one, looking at observability. This has been catching steam as of late with a lot of streaming happening on the internet. Okay, there's something called chaos engineering for disaster recovery. This started with a concept called Chaos Monkey, trademark and props to Netflix. They're the ones who came up with that Chaos Monkey, and then they expanded Chaos Monkey into various different types of tests. So now they have an entire whole suite of various different practices, and now they call it chaos engineering. Okay, and it is a controlled failure simulation. It's to understand the reliability of your infrastructure as well as your code, and understand how resilient it is. Okay. Let's see, we're talking a little bit something called elasticity here, concept of elasticity and scaling up and scaling down, right? How flexible, how elastic is your overall system, not just your application, right? Application is part of your system, right? A lot of people used to think that, oh, my product is my application. No, your product is not just your application, but also the infrastructure on which your application runs. So you have now expanded your testing as a product owner. You're not only testing the digital performance, but you also need to understand how your hardware responds because of your software pressures. Okay, and this is where chaos engineering can really help you. Now, there is something called A/B testing and synthetic transactions. Synthetic transactions are very interesting. We were talking about Capital One before we started the session today. There are a lot of expats who are living outside US, but they bank with Capital One. These are US citizens. And Capital One is one of those banks where they do a lot of stuff online. So when they deploy their product for these individuals who live overseas, they test it on and they simulate that. They will create the routing in such a way that I, as a user of Capital One, could simulate that I'm sitting in, let's say, for example, Australia or India, right? And when I hit their website, I want to see what the latency looks like. How is it the network that causes issues, or is it the application that behaves in a funky way? Okay. Again, we're testing a lot of these scenarios. And based on the use case, okay, if your product has no users outside of your local geography, you don't need to worry about A/B tests or synthetic transactions. Okay. But in today's modern day and age, many of these companies, they've got customers worldwide, globally. So how do they enhance that user experience? Okay, and they test it using this either A/B tests or synthetic transactions. Okay, and then there's the predictive operations. You want to predict. You have a particular infrastructure. You need to predict how it's going to perform on Black Friday, Cyber Monday, or we're in DC area, so we are impacted by government mandates. All of a sudden, government opens up, hey, fill out this form so that we can give you money. And now tons and tons and tons of people are logging onto the website, right? I want to refer it back to the Affordable Care Act website. Okay. They didn't perform any kind of predictive operations or insights, okay, on what is going to happen. And you can run that. All of this observability happens in your production. You simulate, you test, everything is in production, hence the term shift right for that. Okay. Let's see, timing 7:50. I'm cutting it close. I'm going to speed up a little bit. If you have questions, please put it in the chat or ping me on LinkedIn. Okay. So continuous testing. In the BDD diagram I showed you, you check in the code. What happens once the code has been checked in? Once the code has been checked in, you run your entire set of unit tests. All of them run. The new ones that you've written and the old ones that were written in the prior sprints. Okay. And when I say unit tests, everything unit tests, integration tests, component tests, they all fall here. And based on the results, once the thresholds are met, you compile and create an artifact. And that artifact is then deployed into your test environment. And this is where you run your smoke tests, your regression tests. And once again, you measure your KPIs, you look at your metrics, and if the thresholds are met, you promote that artifact into your pre-prod environment. Once again, you follow the same thing. You look for your latency, your performance, your throughput. some of the other tests I meant, or types of tests I mentioned earlier. If all of that looks good, you deploy it into production, and then in production, you continue running your tests, okay? You're constantly testing. And this happens, I have a loop here for continuous testing, because every time a user story is checked in, you run the unit test, you create an artifact, you version that artifact, you move it into your QA environment, and you run all your tests. So every time new piece of code that is checked in to enhance your existing product, your existing application, you continuously test your application. Okay, hence the term continuous testing in a CI/CD pipeline. Okay. Here's another depiction. You've got your local environments, you test, you code, refactor, code check-in, test code. So you could have multiple developers, right, doing this testing, coding, refactoring, and they're all checking their code in. And every time they check in, there's a versioning that happens. It's deployed into your test environment. All these different types of tests are executed in your test environment. Okay, and imagine this is your test environment and your pre-prod environment, okay, all in one. And once it's all green, put it into your production, and you run all these different types of tests in your production as well. Okay, so as you can see, you're constantly testing. Okay, so today testing has pretty much enveloped everything around your software development. Okay, and with that, I will wrap it up, close it, questions and comments. I will share this in a PDF format with the Loud and Agile Network of team, and they will share it with you. This link is a clickable link. Feel free to link me on LinkedIn if we are not already, okay? And with that, I will hand it back to Lakshmi or Toby or whoever else is taking over.
Sure. Thank you, Dhaval. This is Anju. There are tons of questions coming in our chat. So
Okay.
let me start asking from the very end. The first question that is coming from Sheila, or one of the questions is, are the blue-green environments identical? Is the load balancer pushing everything to one, not balancing between the two?
Yes, so the load balancer is pushing everything towards a set of environment, right? So if you're looking at blue, everything is blue. And within blue, you can have different nodes of servers, and you could have another load balancer that is distributing your user base. But on a very high level, it's either you're going to the green environment or you're going to the blue environment. So 100% traffic flows towards one or the other.
Next question is, so in talking about testing in production, is the only thing being tested the look and feel of the front end web pages?
No, absolutely not. You are testing the functionality, how it performs in production. You're looking at the performance, how quickly, and so performance testing is another ocean, so to speak, of information. People also need to understand how their application performs. What I mean by that is, I'll get a little technical here. So every application that's running, they have their own thread. So you need to see what happens to the thread. How is it consuming your hardware, your memory, your hard disk, or whatever, okay? So that's what I mean. It's not just the front end. Front end, sure, it's the look and feel. You definitely want to make it as usable and as accessible as possible, but you also need to understand how it runs behind the scenes. Okay, what happens under the hood, if I can say that.
Also, going back to traditional models with old mainframe systems, it was possible to do large amount of automated batch testing. If there was a batch input capability, either through a database or through flat files with limited variables in each test case. It became more difficult with client server when a build replaced the entire environment and there was very limited or no version control.
Mhm.
It sounds like a passive environment is effectively a pre-production environment, even if it is designated as passive production.
Yes and no. The reason I say that it's because pre-prod, again, there are small nuances here. So pre-prod doesn't necessarily have the same data sets as production. The passive environment will have the same data set as production. Okay, that's pretty much the small difference.
Next question is, when you talk about testing in production, are you including engineering sniffers?
I'm not sure if I understand that question.
Okay, we need more clarity for that, whoever raised that question. Another is, are you testing security in production, looking for incursions?
So what I refer to here is application security. I'm not looking at network security. I didn't talk anything about network security, but yes, you absolutely need to look at network security as well if you're a product owner of the product.
Another question is, traditionally end-to-end testing usually refers to testing the entire application, including all upstream and downstream interfaces. Traditionally, integration tests refer to testing at the enterprise level, integrating through multiple applications. What is being called integration test here? Sounds much more like string test.
So I haven't heard the term string test before, and you're absolutely right. What you're referring to as integration testing is a business flow testing. That's where multiple different applications which are aligned together, upstream, downstream, however you want to look at. And that is referred to as integration testing. What I am referring to integration testing is, how does your code integrate with your database? Okay, how does your application interface with another application? That's the level of integration testing. So I'm moving further down, sort of more, not black box, but closer to the code. Okay, when we run those business flow integration testing, it is more UI based, wherein a tester starts a business flow and behind the scenes stuff happens. Okay, that's not what I was referring to earlier. But you also need to run those tests as well. And
another question from Randy is, isn't A/B testing shift right testing?
it could be. And this happens a lot. I want you guys to not bucket yourself or box yourself into what a particular type of testing falls into. Okay, you can perform A/B testing on lower environments as well. Okay, it doesn't necessarily has to be in production. So you want to always call it as shift right? Not necessarily. Okay, so just again, don't box yourself into that kind of thought process. If you need to perform A/B testing, figure out at which level you need to perform that. For the most parts, most of the times it does happen in production. So yes, you're right, it is shift right. But again, I don't like to box myself and just say, oh, I can only perform A/B testing in production. Okay.
We are right at 8 p.m., but we have just one question. Dhaval, do you want to go ahead and take that?
Absolutely.
Okay. So folks have responded. First, I'll just read out this as well. Engineering sniffers refer to network security as well. And another note is string test refers to testing multiple modules within an application. So another question, I see two questions now. With blue, green, do the two share the same databases with just a different look and feel?
They will share the databases or have replicas of the databases. Okay. So there is, if there is an environment that is active, it is continuously pushing the data into the passive database. And when the switch is made, the data sets are identical. And now the flow reverses because you've gone from active blue to active green. And then now the database, which is green, is now pushing up to the blue. Okay. And there are various different ways of architecting this, depending on the needs of your product. It doesn't have to be a common database, or it can be a common database.
So last question from Sheila. Disagree with the traditional model. RTM allows requirements to be tested and gaps to be found during design. I was a QA manager and sometimes a full lifecycle manager well before the Agile Manifesto. This characterization was not accurate even in the mid to late 80s.
And I'm sorry, what was the characterization?
The traditional model that showed. So she mentions that she disagrees with the traditional model. RTM allows requirements to be tested and gaps to be found during design phase.
Yeah, again, look, there have always been outliers in a good way, and those turned out to be unicorns, right? So, but don't get hung up on what is being generalized here, correct? The presentation is for broad audience, and what were the practices that were used en masse, okay? Not in smaller instances here and there or one-offs. Cool. Any more questions? I'll take one more.
I just see, the extension of the previous answer. If the blue-green have replicas of the same database, are you saying there's a continuous or close to immediate replication between the two?
Yes. Short answer is yes.
So we'll go with the short answer because we are right on time, 8:03. Thank you everyone for joining our session. And thank you so much, Dhaval, for presenting a great session. Please, folks, remember to sign up for our next session, which is on November 11th, where our own Toby Rao and Meenakshi Punjabi are going to present on the topic, Dancing with Scrum Band, the remix of two classics. They'll share their personal experience, tips, and pragmatic guardrails for the real implementation of Scrum Band. So looking forward for all of you to join our session on November 11th. Thank you. Bye-bye.
Dhaval, that was great. Thank you. I learned so much today. So appreciate it.
Yeah,
my pleasure.
Presented.
My pleasure. Thanks, everyone.
Thanks, Dhaval. That was an amazing session. Look forward for.
Yeah, absolutely. Thank you so much, Dhaval.
Absolutely. It's my pleasure. All right. See you guys.
See ya. Good night, everyone. Thank you.
Bye.
So we drop off. Chalo, Anju, good night.
Chal.
Happy Diwali in case we don't see each other again.
Stop recording.